Alrighty, we will start kicking things off. I've got a bit of a preamble while we wait for a few more people to join. So yeah, welcome. My name is Nathaniel Butterworth. Feel free to call me Nate. I have a background in geophysics and data science. Now working at Google, helping researchers use the latest and greatest AI technologies. So obviously 4 hours is a long time together, so we'll aim for regular breaks on about the hour. Feel free to keep your camera on or off throughout the session and be as interactive as you feel comfortable. You can unmute yourself or just post any questions you have in the chat as they come to you, and I'll get to them eventually. I've been using Python for far too many years now, maybe 15, 20 years now. And I've seen many of the typical workflows and challenges that researchers and research scientists face and the kinds of things they want to use Python with. So I've sort of built these notes around fundamentals, which are applicable kind of anywhere, but also leaning in towards more research problems. So hopefully today's sessions will build towards using Python as a tool for your own research and also introduce you to all its AI capabilities. So Python is like the language of choice for AI development and application, and give you just a peek into what may appear kind of as a black box for a lot of AI sort of applications. And hopefully you can better understand how these models work. And that way you can hopefully build more strategic analysis pipelines or whatever you need, sort of knowing the inner workings of them all. Alrighty, so I posted the notes in the chat that I'll be following along here. So they're in this format. Now, I should introduce this to begin with. This is called Google Colab, and it's basically a way to use Python in a web browser, and it's in a type of format called a Python notebook, or just a notebook. And you may have a different, what's called an interactive development environment, IDE, if you want to run Python locally. So you may use both like a different application to view the Python code and also run the Python program. And that could be something like VS Code is very popular, or Notepad++ on some platforms. Or you could have something like Anaconda or Miniconda, or and use those sorts of platforms to interact with Python. So there's lots of different kind of like ways to set up your what's called your Python environment and your workstation, I guess. But Google Colab is fantastic. I think it's very accessible. In one click and you get yourself a Python interactive Python terminal, and you don't have to do anything else. You don't have to install it. You don't have to host anything. You can just run things as you wish. Okay, so and I'll talk through sort of some features of it as we go along. But yeah, just giving you that sort of context for what it is and a few other alternatives. Okay, so yeah, as I mentioned, we'll be working through these notes at a steady clip. And what we're going to do is actually, we're not going to use this notebook. We're going to start a fresh notebook and run from there. But all the answers, I guess, everything I talk about should basically be in this notebook. So you might want to keep a copy of the notebook open along with a fresh one. So here's the first thing everyone has to do. Hopefully everyone's navigated to this page. So I'm just catching up with the chat. Yes, this session is being recorded. I think it's the record button. Yes, the record button has already been clicked. Fantastic. Thanks for that. So yep, it'll be recorded and posted shortly after we finish. Okay, so is everyone with me? Go to this page, the links in the chat, and what you're going to do is go File, and then New Notebook. So step one of today, and we will have a blank screen staring back at us for us to fill with all our own code and go from there. All right, cool. So it just started. immediately start coding or generate with AI. So yeah, we won't use any of these sort of generate with AI features today, but it is really cool. Like everything's embedded there, and you might see some prompts pop up saying like, hey, do you want to complete this command? So it is quite good, and you can and hopefully the skills you learn today will be enough to sort of ask questions of AI, like please write me a function that performs these tasks, and then you kind of see if the Python code is correct or not. So you can do that all from within Colab using the integrated Gemini features. But we are going to start from scratch. So the very first thing I'm going to do, I'm just going to clean up mine and make it a little bit more. Actually, I'll do that in a second. I'm going to put a hash and say, hello, this is a comment. It is for humans only. So this is what's called a comment in Python. When you run your Python code, so when you send the text instructions off to the Python interpreter to execute some tasks, anything starting with a hash is generally ignored, and it's just for the humans, for yourself later on when you come back and say like, what was this function for? What is this feature? So we'll see that quite a bit. So I'm going to put a new line in there. I'm going to go print. That's a Python keyword reserve function. Say hello world. And so that's a syntax. So we'll talk a lot about the syntax and the style that we have to use in order for Python to work properly. But basically, we open a parentheses after writing the print word and put what's called a string in there called hello world in between two double quotation marks, new symbol as well. And then I'm going to click, there's a few options here. You can click the play button to run the cell, or you can press, okay, wait, it's thinking. Sorry, so it's up here and it's just connecting. So the first time it takes a little bit. It connects to some remote compute resources in Google Cloud Platform. So we get sort of, yeah, free virtual machine somewhere. And there we go. So it's printed that by clicking that play button. You can also go, is it run? Yeah, you can run it using the menu up there, or you can press Shift Enter. I think normally does trick. I think Control Enter does it and doesn't take you to the next one. Shift Enter takes you to the next one. So there's a few ways that you can kind of execute code. All right, well done. You've all written your first Python script. Great job. Any questions so far? Good stuff. Fantastic. Let's keep going strong then. So we will continue with some fundamentals. And so this is true for like kind of all programming languages. I'm going to introduce something called variables. So you can leave that code up there. And down here, we're going to create a variable where we'll store some information inside an object. And so following the notes, I can say project. So I have the notes open in another window. So project name equals, and I won't use what the suggested thing is there, but I can call it like my study. All right, and so now I have this thing. I can run that immediately. Now I have this object called project name, or a variable called project name, and I can print that out. So print project name, and it says it there. I can go up and change this to, my like, give it a proper name, like yes, metabolic underscore 101 or something, and then I re-instantiate that, and so it overwrites what was in project name, and I can run it again, and it will be updated there like that. Also, a neat feature of notebooks is you don't actually have to put the print statement in for the very last item, and it will just kind of print it out in there. So that's a little feature we can use. I'll just minimize my screen, or maximize my screen real estate here. Okay, so yeah, so that's a variable. For a variable, you can store all kinds of data. I'll keep using that cell. So this is called a cell, I guess. It's a Python cell, and the nature of the notebooks is they flow from top to bottom, but you can kind of like jump back and forwards. But you have to keep in mind like if what's in memory and what's not, and we'll talk about that as we go. So we can do number of samples equals and store what's called an integer. So I'll just press enter. So I haven't executed that yet. I can do pH level equals, there we go, 7.4. So that's a this is called a floating point number. We can do other things like results equals true. This is called a Boolean statement. We can also make that false. So that's true or false. That comes up a lot in all kinds of programming languages because you have ones and zeros, basically true or false, on or off. Which logic gate should I go down? So that will be useful. Okay, and then yeah, we can print all these items out. So we've seen. Sorry, I have to run this. Make sure I run it, and then into the project name. I can print out number of samples, good stuff, and so on. You can print all the rest out if you want. You can also get the type of these. So I mentioned the type, but if you don't believe me, you can use the keyword type, and we'll say that's an integer. Let's do the type of pH level. It's a float. Type of results would be a Boolean or a bool. There we go. Okay, so that's variables 101. That's kind of like everything is to know about that, and from there you build upon it. And so the next thing, Python's basically a big old calculator. It's got all these built-in arithmetic operators and so on. So you can do things like pH level plus 1. And it's going to be 8.4 because pH level is 7.4 plus 1 is 8.4. Or you could do, minus 1. You can do multiplication times 10 times 10, division, and so on. And then you have the other ones like modulo, which is the remainder of a division. So pH level is 7.4 divided by 2 is should be 3 with 1.4 left over. A little feature, I guess, of or a fact of dealing with floating point numbers. You'll see it's sort of rounded to some really precise decimal place there, and this is just kind of like a function of you can only store so many bits on a in a piece of memory. So sometimes you get these weird little additional significant figures there, but not to worry about. Okay, and what else can we do? So you can do comparisons. So you can do things like 1 equals 1, and that this is different to assignment, which is a single equals, but a double equals is it checks one side of the equation with the other. So does 1 equal to 1? Yes, that's true. Is 1 equal to 2? No, that's false. Can we do 1 equals pH level? That's false. What about 1 equals project name? That'll be false too. So you can do all these sort of comparisons, and you can imagine how that would be handy. Like you want to check something and be like, is this the same value as that? And if you get a true or false statement, you can use that to your advantage. Okay, so then you can also do things like not equals to. So you can do an exclamation mark. So is 1 not equal to 1? That's true. Let me put pH level back in. So is 1 not equal to the pH level? Yes, that is true because it's not equal instead of equal. You can do greater than. So that's false. 1 is less than 7.4. So if I do less than, I'll say it's true. And and you can do less than or equal to. So is 7.4 less than or equal to pH level? That is true. Is it less than pH level? That is false, and so on. So lots of fun things with that. Now you can also do logical operators. So you can have let me think about this. You can have things like 1 and 2. So that's saying it checks. Sorry, that's probably not a very good example. Let's choose results, which is set to false, and we can set a new variable, or we can just write the word true. So results and true. So this is saying, are both of these equivalent to true? And the answer is false, because results is set to false. And you can do things like, what about or? So this is saying false or true, and then it will default to true. So we can get into the choices that are made by these Boolean operators, logical operators, sorry, as we go forth. Okay, so that's that. So let's now we can store all these items in various data structures, and one of the most, I think, common Python ones that you'll come across is called a list. So let me make a list. Temperature readings. Oh yeah, and whilst I'm making this, there's certain rules around what you can set variable names to. So let me just do temperature readings equals 1. Okay, that's good. What if I do, 1 underscore temperature readings? And there we go. That's our first error. So it says invalid decimal literal. And reading errors is a big part of, I guess, learning Python. So understanding, what's there. So this error that's come up, invalid decimal literal, it's actually got nothing to do with the mistake that I made, which was setting a numerical value as the first value of the variable name. So yeah, being able to interpret like what the error is and then what it actually means, it takes a bit of practice. So you can have temperature readings _1 at the end. So that's fine. Yeah, and there's a few other. I don't think you can't have like special characters in there. So again, this error, syntax error, cannot assign to expressions here. Maybe you meant equals or instead of equals. No, I just made a typo. So, all right, so I'll set it back to temperature readings. All right, so yeah, they're just the rules of the language. Different languages have slightly different rules, but I think Python does a pretty good job at sort of making them quite reasonable. Okay, so I'm going to teach you about lists. So to create a list, all you do is put a square brackets there, and then you can fill the list with whatever you like. So here we can fill it with 22.5, 22.7, 22.8, 23.1, and so on. And so then I have a list. I can say type temperature readings, and it's a list. I can now access different parts of this list. It's that same thing. Temperature readings 0. So Python counts from 0. So in this list of objects or items there's 4 of them, but Python counts the index of those from 0. So that's the 0th index, the 1st index, the 2nd index, and the 3rd index. And you can say 0, 1, 2, so on 3. And if I went to 4, it would say, again, this error is actually useful. So yeah, whenever you read an error, generally the most important thing is right down the bottom. So it says list index is out of range. And so that implies that I've gone to the fourth index, but there is no fourth index. And so a good way to go to the end index, you can go to -1 instead. So that gives us the last value, whatever that might be. If you don't know how long the list is for whatever reason, you can do slice a list. So you can say, give me from 1 to 3, and it will give you the first index, which is 22.7, and then the next one, number 2, which is 22.8. So it includes this number, but does not include that number. So it gives you 1 and 2, but not 3. Just details and rules of the rules of lists. And you can do things like you can append to lists. So there's different let's go temperature make sure readings dot append, and you can say 50, some anomalous reading there. And now if I look at temperature readings, temperature read, you can see that has been added to my list. So there's different things you can append, you can remove. You can find the length of temperature readings using this len keyword. Anything else interesting? I think that's it. I think, yeah, there's various other these are called methods that we'll learn about as we go. So a method is kind of like an operation that you can perform on some sort of data type or data structure, and different data types and different data structures have different methods and attributes associated with them that you can perform tasks on, depending on what type it is. So if we try to append to something like if we tried to append to a float, for instance, like it would say, append is not a thing for a float. Attribute float object has no attribute append. So things like that. Okay, so of course, I'll add another one. I'm going to run that again, and now if I do this, it's now 6. Okay, that's the list. Lists are fantastic. We want to talk about anything else? We'll talk more about some more data structures shortly, but we can immediately go to sort of the some control and flow statements. Any questions in the chat? All good? Good stuff. Fantastic. Keep pushing on. So yep, so we've covered, we're flying through, we've covered the basic variables, operators, comparison operators, logical operators. We've done some list work, and now we're up to this module 2, control flow and functions. And here we're going to introduce this concept called an if statement. So this it's the natural plain English explanation for what an if statement is. So if I want to do something, I have to perform some or satisfy some condition, and then I can do it. Otherwise, I want to go do something else. So Python uses the keywords if and else, and also if elif. Okay, so for instance, let's set ourselves up. P value equals 0.065. Can put comment in control and functions. Put another comment in, set initial value. Okay, so p value equals 0.65. So if, and make sure from the start the capitalization matters. Make sure it doesn't matter if I did the first one as a capital, but if I have to be consistent from that then on. So if p underscore value is less than 0.05, let's do something. So that's a syntax. So if some condition, that's the condition, p underscore value is less than 0.05, and then a colon, and then after the colon, when I press enter, you'll see, so I'm going to press enter, you'll see that it automatically indents the cursor. And so this is somewhat unique to Python in that Python doesn't know, or there's no place to say, here's the end of like that previous statement. The way it actually does it is using white space. So it uses indentation to say that was the end of that statement, and now Python interpreter start reading the next thing as if it was a different statement. So whereas things like C++, that you have to put a semicolon in, and you don't actually have to do any new lines in C++. You can just write forever on one line. But Python, it forces you to write sort of neat code by doing indentations. So, okay, so I'm going to go, but that's just a bit of a sideways into the, inner workings of Python. So let's just print p-value if, and I can say it is, yeah, there we go. That's is statistically significant. Cool. So I've done my first conditional statement. I've said if p-value is less than 0.05, print this. So I'm going to run this. Nothing happened. Fantastic. That means the p-value is not less than 0.05. In fact, I know that it's 0.065. So we can put some other conditions in. We can say, well, what if we do L if p underscore value is less than 0.1. Okay, I'm liking where this automatic text is providing for me. So I'm going to do that. P-value is moderately significant. Sure. Okay. All right. So let's check this now. And oh, look at that. So this has checked. The first thing it does is check whether this is true. If this equates to true, it prints that. If it doesn't equate to true, it will go to the next line, and then it will then check this and see if that's true. If that equates to true, it will print that line. We can do one more to catch any edge cases. So else, and that's it. We just have to write else. So that just means else for everything else. So print p-value is not significant. Cool. So I run that, and again, we're always getting that middle value. So we can change this. Let's change it to remove a decimal place there, and I'd expect this to be false, this to be false, because it's going to be greater than 0.1. And so if I run that, and it says it is not significant. Cool. So if it was something like 0.05, do you expect that to be true? I think it's going to be false because it's not less than or equal to. So this one will print. It's moderately significant. Good stuff. But if it was even smaller, 0.01, for instance, it should hit that first one. That equates to true, and then none of the rest of this code gets ran. So keep that in mind. It will run this first, and then everything else doesn't get run. Okay, cool. So that's yeah, that's basically if statements. So these are super powerful. You can, with enough if else statements, you can turn the world or something. All right, so from if statements, let's go to something called loops. So loops. So basically, there's two main types of loops: a for loop and a while loop. So a for loop says keep for every item in some provided list of items, do something. And so let's do that. And in fact, I like this, what it suggested for me. I think you can turn this off too, by the way. Some people may not have this auto word suggestion on. I'm going to go for T, I'm lazy, in temperature underscore readings. And then remember, that's this thing that we defined up there. So hopefully you have this list of temperature readings already defined. And it says for T in temperature readings. Well, to start with, I can just say print T. So we'll go print first one, print second one, print third one, print fourth one, print fifth one, print sixth one. Fantastic. You can do other things as well. So you could do, print hello. And for every single item, or maybe something more temperature. There we go. We can do temperature, and it prints the word temperature every single time it goes through the list, and then it also prints this T value here. So that's basically a for loop. There's all different ways to define what the for loop is looping over. So you can do like a range of numbers from 0 to 1,000,000. You can do a list with all different items in it. You can do you can even do something like, here we go. I'll use project name. So for doesn't matter what you call this defines like a temporary variable. So I can just do for letter in project name, print letter, and it actually loops through the string one at a time. So you can do things like that. Anything else interesting? I think that's kind of it. We'll see for loops a few more times before we finish. And the other one I'm going to look at is while loops. So I find for loops, I don't know, they seem to appear more often than while loops, but while loops are very critical as well, especially if you don't know sort of how long something is going to go for. So you can say, keep doing this forever until some condition is met. So let's define, what have I got here? Oh, sorry, I will, where's my while loops? Okay, so I've got for, I'm going to go current concentration equals 0.5, target concentration equals 0.9. Let's go reaction step equals 0. Okay, and then I can say while current concentration is less than the target concentration, do something. So each time we go through our loop, we probably want to update our reaction step. So it starts at 0, so we can do this is a neat little trick in Python. I think other languages have similar features. To say add 1 to this reaction step, you can use the syntax plus equals. So that's the equivalent of saying reaction step equals reaction step plus 1. So it's kind of like a shorthand to do it, and it's handy to sort of visualize that as well, because it's clobbering the old value and replacing it with a new value. So that's why it's kind of a good way to write that. Okay, so reaction step plus equals 1, and so at the moment, as we go through our loop, if you run it now, this will run forever. So don't run it just yet. Maybe I'll run it just for fun, but you shouldn't run it. It's just going to run forever and ever and ever and ever and ever. I'm going to click stop. There's a few ways to kill it, but that's one way. You can even see where reaction step got to. There we go. It just got to what's that? 19 million in that short amount of time. So it would have kept going until we ran out of memory or something. But because it's going to run forever, because this condition is never like updated. So we need to update our current concentration so that this condition will eventually be false and it'll stop running. Hopefully that makes sense. Okay, so you can do something like current underscore concentration plus equals, let's say 0.1. And now when I run it, there we go, it ran and it finished. And so now if I see my reaction step is 5, so it ran through 5 times before it stopped. My current concentration is 0.999. Again, that's equivalent to 1. So computationally equivalent to 1 and mathematically, I guess. And we can do other things as well, like you can put other break statements in there. So say you kept updating this value, but you only wanted to look at the first 10 of these, so you weren't sure how many were going to occur. You can do something like if reaction step is greater than 100. So we put an if statement inside our while loop and say print, emergency stop. And then you need the word break. The break just escapes you from a loop that you're currently in. Okay. And yeah, let's also, I'm going to put a print statement where I'll print the current underscore concentration and reaction step. Okay. And just note also my indentation. So I have the if is inside the while loop, the print is inside the while loop, but it's outside the break statement. So keep that in mind. Okay, so I'll run this and it should print it 0.61, 0.72. Yeah, so it's doing that rounding thing, 3, 4, 5. And it looks like it broke because that condition was satisfied. So it went there. Cool. So I could do something like this, and then it will break. It will run the emergency stop. So I ran the emergency stop there because the reaction got up to 100. Okay, good stuff. So let me just redo that at a lower number. So my output isn't filled with all that output. Okay, any questions on that? So that's while loops and for loops. Easy, love it, fantastic. We'll keep pushing ahead. So we've done variables, done loops, done conditional statements. Typo somewhere there. Okay. Next in the notes, so loops, done functions. So what time is it? Yeah, I think we should. Yeah, we'll do functions and then we'll have a break. Okay, so a function, we've already used a couple functions, which are built-in functions. So these are sort of reserved keywords. I'm confusing some terms here. There's things called reserved keywords. They're things like while and if and break. And then there's also built-in functions, which are like print. And have we used anything else? I think we've only used print. Oh, and I guess type is function as well. So we're going to write our own function, and that is basically like a reusable piece of code that we may want to have some control over and write ourselves, and then you can do whatever you want with that. Okay, so let's do it. Yeah, the basic structure of it is that we use this keyword called def, so define, and then you give it a name, and then any parameters that the function needs to operate. So that could be like adding 2 numbers together, or so you might need to take both numbers. And if you have extended comment blocks, this is called a doc string, basically 3 quotations in a row, and then you can write, this is for the humans as well. It's kind of like a comment, but a really extended comment. So good, well-written functions often have documentation explaining what a function does, and then the actual code itself for what's happening in the function. And usually a function will return some value. So it does some work inside the function, it returns the value, and then it gives you that output. Okay, so let's write this function called Celsius to Fahrenheit, which a good function. So, function temperature converter. Okay, so I'm going to go def Celsius to get my notes so I don't spell Fahrenheit incorrectly. FHR Fahrenheit. And then as input, we probably want to take the temperature in Celsius. So the suggested code here is good. I'll basically copy that. Celsius, call it temperature, and then you do a colon, and then Python should automatically indent for you. If it doesn't, you have to do the indentation. And then we need to do something with this temperature that we're defined. So let's call it Fahrenheit. Make sure I spell it right. F-A-H Fahrenheit underscore temperature equals Celsius plus temperature times 9 divided by 5 plus 32. Now you can see I'm doing so yeah, parentheses are calculated first, so following your typical BODMAS rules for Python. I'm doing spaces in between things like the various operators, like the equal signs. This is just good style, and Python doesn't demand that, but there are style guides, and I think I've linked to it in the notes, that suggest, this is a better way to write it so things are more readable. And there's some agreed upon standards that a lot of people use. Okay, so that's the equation for converting Celsius to Fahrenheit. So times 905 plus 32. And so that gives us the Fahrenheit temperature. And then we return the Fahrenheit temperature, Fahrenheit temp. Making sure to use all lowercase in this case. Okay, so that's it. I've written a function, I run it, and nothing happens, which is good, because all I've done is define the function. And so now if I want to use it, I can type in Celsius underscore to underscore Fahrenheit, and then I can just give it a number, so 50, and it returns, takes 50 in, times it by 9 over 5 plus 32. That sounds about right, and gives us 122. And I can give it 20. And I can give it 10. Oops. I pressed enter instead of shift enter there. Fantastic. I can even do 4F in temperature readings print. So you can imagine this is very powerful. I should do T. If you want to do something like millions of times, or in this case 6 times, it's going to take all our temperature readings that we defined before and run that function again and again and again. Cool. So yeah, so that's a really basic function, but I mean, from there you can build it out. So we can do another slightly more involved example from the notes here. We calculate the average of some numbers. So I'm going to define calculate average number list. I define that. I'll write a doc string this time. So I'll do 3 quotes. And so this is my first function. It takes the average of a list of numbers and returns an integer. And often you'll see in these doc strings, it'll say something like args, which means arguments, which is that number list. So I can write number list and then a description of the type. So maybe it's like a list of numbers. Good. And the returns an average, which is a float. So you often see things like that. I close the doc strings, and then I can do something like total sum equals, use the built-in sum function, numbers, and it's called list. So number list. I'm doing number list in the notes is numbers list, and I'll make it consistent. Very important. I can go count equals the len of numbers list, and then the average equals the total sum divided by the count, and then we return the average. Cool. Let's see. Maybe I should have made some mistakes so we can learn from it. I'll find out in a second. Okay, so I still have my temperature readings. So let's get the average of those by going calculate average temperature reading. Fantastic. I got an error. So it says name error. Temperature readings is not defined. I feel like spelling mistakes are one of the most common issues here. So I've done 2 P's in that. So sometimes you're scratching your head going like, I know it's there. It's definitely, I can define it. Or if you do an O instead of a 0 or something, very confusing. Okay, so I just made a typo. So I fix that up. I'll run it again. And this time it works. So yeah, that feels about right. About 32. So there's our function that we've written. And you can see, yeah, that one's got a few more steps inside it. You can do things like return multiple values. Yeah, you return all different data types. So you can return lists, or I think you can even return functions, do all wild stuff. Okay, so any questions that people have? So from here, this is, you've just learned like the basics. From here, you can build anything in the world with enough if statements, for loops, and everything. But we'll show you a shortcut for that when we come back. And yes, okay. So when we come back, we'll talk about the introduction to various scientific libraries and some packages. So let's have a 10-minute break, and I'll see you all again soon. Feel free, if you come up with any questions, feel free to post them in the chat or whatever. For those who maybe came in late, the next step is completely standalone, so you can catch up very quickly. I'll put a timer on, and all righty, everyone, welcome back. I hope we've all had a good moment to stretch our legs and digest everything we covered in the first session. Sorry for those that couldn't join. Hopefully you've managed to join now. Where we've basically just covered real basics. So the Python fundamentals, so different data types and variables, and defining sort of some Python syntax and style. We've also introduced the concept of Python lists and objects for storing data, and we'll talk more about other objects shortly. and spoken about control flow and functions, so using conditional if-else statements, and also loops, including for loops and while loops. And we've also defined some functions and seen how we can use functions. We're going to now use all these fundamentals as we go, so we'll revisit all those concepts continuously as we push forward into more perhaps industrious parts of the course today. All right, so in this next section, so imagine you have written a function or thousands of functions, and you think, wow, these functions are fantastic. I'm sure other people would appreciate all these functions and data structures that I've defined and written all this code for. I'm going to release these into the world, and so you can release a package, a Python package or a Python library, and you can then go and install it, and then other people can use those packages as well. And this is really what makes Python so powerful: the fact that it's open source and people have contributed to it over a lot of time. And so now there's tens of thousands or millions. So let's have a look. So this website, PyPy. Here we go. There's 658,000 projects. PyPy lists is a package indexer of basically libraries that people have put together themselves and released to the public. So we can pull packages from this indexer called PyPy, or there's a couple others as well. So Anaconda is probably the other really big one, or Conda. And yeah, we'll see sort of some major libraries that we'll use, and then how to use them. Okay, so I'm going to open up a new notebook. You can maybe use your same notebook that you had, but feel free to click on File and New Notebook. We'll wait for a moment for it to load, and good stuff. So now the way that you load functions in, load libraries in, and thereby getting access to all the functions that people have written in those packages, is saying like import NumPy. So NumPy, or numerical Python, is probably the most popular secondary package, outside of core Python. So import NumPy, and a lot of people use a shortcut because they're lazy. They can't be bothered writing NumPy all the time, so they write as NP. So it's just a little shortcut, little convention that people use. And then from there, you get access to this wonderful numerical Python library. Again, so I just ran that by pressing the play button, or you can press Shift Enter and import this package. So numerical Python, we'll look up NumPy. Here we go, NumPy. Yeah, it offers comprehensive maths and scientific computing, and so a lot of array sort of manipulation in NumPy, and it's really well optimized as well. So it's actually, a lot of NumPy functions are written in like faster programming languages like C, and so here we go. Yeah, the power of C and Fortran. But you don't have to worry about that. You just say, do this dot product, and it will do the dot product, and it's compiled down in the system level, and it then exposes it to Python, and you run it through Python. But it's super quick, and yeah, there's a lot of things there. Now, reading the documentation of packages like NumPy, and we'll see a few others, including SciPy, Matplotlib, Pandas. Reading the documentation, again, is a sort of like it's a skill in itself. So I think if you search for, you'll often find yourself on the, I'm just trying to find anything, scalars. So yeah, you often find yourself in in searching for something, and you'll come to the like NumPy documentation, and yeah, being able to read this documentation again, I think is kind of like a skill in itself. But it does explain sort of how to use a bunch of different functions, and what they're for, and the logic behind them, and gives examples for how to use them. So we might see a little bit of this as we go. But yeah, there's the math behind what's going on in this. I just picked a random one here. What is it? The oh yeah, it's the array function. So that's actually one of the biggest core features of NumPy, is that it embeds things in an array. And it works. So an array, which we'll see very similar to a Python list, it can behave a lot differently and has sort of access to these really fast libraries. Okay, cool. I digress. So yeah, we can import it like that. We're using Google Colab. So in Google Colab, it has a bunch of these packages pre-installed. If there's a package that's not there, or you need like a newer version, you can do pip with an exclamation mark and say install NumPy. And it will say, okay, I'm going to go install it, but it's already said requirement already satisfied. And it says what version we've got, 2.02. And yeah, but if you're on your local computer, pip install NumPy is the way you get it as well, most likely. Or you might do conda install NumPy if you're using conda instead. Okay, cool. So let's let's just have a look at some of these examples of NumPy, of what it can do. So I'm going to firstly create a Python list, much like we had before, temperature underscore list underscore pi equals, and then in Python we define a list of items here, 0.8, 23.1, 23.9. You can make these up if you like. Follow the notes. You can copy and paste if you're desperate. Okay, so there's a list for us, and it behaves like a list. Temperature list pi. Sorry, I just pressed tab to auto complete that then. So yep, it's behaving like a list. It looks like a list. Fantastic. What we're going to do is convert it into a NumPy object, and so, or specifically a NumPy array. So to do that, we can set a new variable, temperature underscore list underscore np equals, oh sorry, following the notes, we'll call it array. It's actually an array, not a list anymore. And then we can go np.array. So there's the NumPy method that we need to use, and that will convert it, this thing, to a NumPy array. I can look at that, and it prints out, you know, fairly similar. The numbers are the same. However, I don't know why it's hyperlinking there. However, it has this word array, and it also has parentheses and then the list inside it. But it is now an array type object. That's you know, the developers of NumPy said, how do we create these array objects? And this is one way to define them. Take a list, a Python list, and wrap it around an array, and then everything inside that will then have access to the NumPy array functions and methods. Okay, so in this array, we can get some attributes out of it. So if we do dtype, it'll say what type of data is inside that. So this is called a float 64. So that means there's 64 bits of data that are stored, that each of these numbers occupies. So it's kind of like 64 decimal places, I guess. So it can be a massive number. And, you know, if you're dealing with like crazy large objects or something, and you need to save space on memory, then you can convert these to 32-bit objects and or 8-bit or 2-bit, depending on what you need to do and how much speed you need to do and what compromises you need to make. So it has a lot of like real low level sort of features that you can access. Okay, so you can do things like what else do we want to do? So we just see that question. If a list can have different data types, does that mean a NumPy array can have different typed items in them? Great question. No. So a list can have all different data types. It can contain strings and can have lists of lists and lists of dictionaries and floats and whatever. So NumPy is numbers. So you can basically have one type to rule them all in NumPy. So it can be integers or floats, but you can't mix them either. So it will be all of them. But that's it. Yeah, again, the trade-off between sort of speed and versatility. Okay, so now from here, if we want to convert all of these to Kelvin, we can do something like plus 273.15. I'll just do that so you can see the whole array automatically gets this. Now, if I did temperature list pi plus 273.15, is that going to work? No. So it says type error can only concatenate list, not float to list. So you can't just sort of add a number to a list like that. Whereas a NumPy array, you can add a number to every item in the list almost instantly. Like it's super fast. Actually, instance, not a great word. Very quickly. Okay. We want to save this as a Kelvin. Let's scroll up a little bit. Kelvin underscore temperatures equals NumPy array. So I'm going to save that. I'll print it out just underneath as well. You can see it. And now I can perform lots of operations on it. So I can do numpy.main, and then I can either do it on my Kelvin temperatures. Yeah, let's do it on my Kelvin temperatures. So numpy main. So it gives me the mean of all those numbers. Or maybe I'll do it on these ones. So we're dealing with more palatable numbers. Okay, so the average of the average temperature is 22.9. We do numpy dot standard deviation. Again, I'll just paste that in. Temperature array underscore NP. So the standard deviation is that. There's a max value, NumPy max. Temperature array NP. So that's the maximum. It's probably a minimum as well, and all other sort of typical statistical measures. Anything else? So let's now you can so yeah, some list methods are interchangeable with NumPy methods, but yeah, and it depends. Like sometimes they behave slightly differently. So you get a maximum of. You can use NumPy max on a list, I think. Let's have a look. Yeah, you can use NumPy max on a list of items. So you don't need an array, and but it might behave differently, or maybe one's faster or slower. There's sort of different scenarios where one might be better to use over another one. And there's also a built-in function, right, called max temperature list pi, and can that get the max of the temperature of the NumPy array? Yes, it can. So you can use the built-in max. You can use NumPy max. Yeah, different scenarios. I don't know the answer off the top of my head why you use one over the other, but I know that yeah, sometimes you may want to use one instead of the other. Okay, cool. So yeah, NumPy, it's very vast, depending on how deep you want to go into numerical Python, but we won't dwell on it too much. I'll just do one thing here that's in the notes is which is a bit of a side thing, is these things called F strings. So instead of writing like, I'll just do mean temperature, and then I'll do a comma and do NP dot mean temperature array underscore NP. So this is one way you can print kind of two items next to each other. It will print the mean temperature, and then by default, it gives you a space, and then it prints this value here. Now, there's this concept called an F string, which gives you sort of power to manipulate the string in a much more like nice fashion. So I'm just going to copy this, and I'm going to put an S out the front, and then delete my commas here. And the way F strings work is they use curly braces around the variables, so around like the objects that's saved in Python that isn't just a string. And you can do a colon and then something like a 0.2f, which will give me two floating point numbers. Is that what the F stands for? Maybe fix. It fixes it to two decimal places, basically. And then you can do something, I don't know how to do the degree symbol, so let's write degree C, and then close that. And you can see that looks a lot nicer when it prints. So these F strings are super useful to use instead of just printing it out like that. So that might come up a few times. Good stuff. Any questions? Okay, cool. So let's import another package called Pandas. Import Pandas as PD. So Pandas stands for panel data, I think. It's basically a big Python library you use for table manipulation. So if you're coming from somewhere like Microsoft Excel, Pandas is like the replacement for using big table data like that. And it can deal with all the different data types and everything that NumPy can't necessarily do it. Again, documentation of Pandas. It's a learning experience to know how to read the documentation, but you'll often find out. So if you type in like Pandas sort or something, there we go. So if you want to sort the values of a table, and you get this thing, and that looks like a different language. But it explains, there's this thing in Pandas that operates on these objects called data frames, and the syntax that you use for that method is sort values. And then here's all the options for that function. So just like when we defined a function, you can define all these ones. Some are optional, some are not. And then it explains how to use each of those different options there. So then it has some examples. So yeah, reading the documentation can be it's a learning experience. Anyway, so we'll have a look at Pandas real quick. We'll use that a little bit. So in the notes, I'm going to define what's called a dictionary. So this is another Python type. I guess it's kind of like a list, but it is, dictionary is really cool if you know JSON. So it has a key and a value. So in this case, the keys are on the left-hand side. So sample ID, treatment, measurement OD, replicate, and then just strings. And then you have a colon, and then the value of those keys. And so in this case, that one is a list. Sorry, they're all defined as lists, but they're lists of strings. These ones is a list of numbers there, or of floats, and here's integers. You might just have a single value for them as well, but because we're going to import this in pandas, we want kind of like a table of data. And so you can imagine they're the column headers and they're the values in the columns. Okay, so let me type that out. Feel free to copy and paste it if you want. But data dict equals, so you open up a curly brace and then I press enter and it's kind of prompting me to do things. Sample ID, colon, got S1, S2, S3. You'll notice I've done double quotes instead of single quotes. There's no real I think that there's some style differences, but the behavior is about the same. You just have to be consistent. So if you open with a double, you have to close with a double. But it's a good way to use nested quotes. So if you had like in here, you had a quote inside a string, you might want to retain that information. So you might have single quotes on the outside and use double quotes for the quotes inside it. I'll just keep going with double quotes here. Treatment, colon, control, drug A. And no matter what IDE you are using, you'll find that they have various like syntax highlighting. So I haven't spoken about that, but the strings are red, the variables are black, this syntax is blue, purple for keywords, and so on. There's syntax highlighting, and a lot of them have code completion as well. So you'll go to type something, you'll say, "Hey, do you want to use this? Do you mean the uppercase? Do you mean the lowercase?" So on. Okay, 0.15, 0.78, 0.24, 0.95, 65. Okay. Cool. So we've set up some experimental data that may or may not have been in the dictionary already. Probably was 1, 2, 1. Let's see, I'll run that. Fantastic. Data dict. And yeah, you can see our data dictionary there. I can do type data dict, and it's a dictionary. And now, if I want to convert it into pandas, so I can make use of the pandas features, just like we did with NumPy, we go df equals pd, which is pandas. So that's sort of how you start all pandas operations. You start with pd or pandas dot, and then we're going to turn it into a data frame, just like we did with np array. So NumPy uses arrays, pandas uses the concept of a data frame. If you're coming from R, then yeah, the pandas data frames work very similar to R data frames. And yeah, df is you'll often see as the default naming convention for a data frame. So there we go. It looks really pretty. Yeah, there's our columns, there's our rows, a row ID, and the values for each of them. Super duper. So then we can go, and now we have full control of this data frame. We have it in this structured format that we like, and so now we have access to all these methods and functions that might be available to us. So we can do things df.info, and it gives me info about the data frame. So it says, what number column it is, how many values there are, how many are equal to null values. So they could be, if there was any missing data, if there were nads, not a number, that might come up in these counts, and then what type it is. Are they floats? Are they integers? Strings are defined as objects in pandas, which are kind of like everything else. It says how much memory this thing's using, and anything else interesting. Yeah, I think that's it. So there's df info. We have df describe. So data frame describe, and it gives us all these details here. We can look up data frame describe with the documentation, and you see I open parentheses and close them. These are all optional variables, but I can add a few kind of variables in there to give me something else. So there we go. If I do percentiles, let's do that. df describe percentiles equals 0.25. So it's giving me the percentage of data points that fall in the 25th percentile and the 50th percentile and so on. So you can adjust the defaults that come out of this. And yeah, and you'll see this describe function, it sort of dropped the 2 string columns because it's only relevant for things with numbers on there. Good stuff. What else have we got? So we can look at the head. Head shows us the top few lines. We'll put in a number there, say give us the top 2 lines. Same, we can do tail. The data frames, you can do the shape. Now, shape doesn't have parentheses. It's a, as opposed to a method, I think it's an attribute of the data frame as opposed to a method of the data frame. So yeah, as we saw just described, it's a method of the data frame. It's kind of like a function that applies to that data frame. So if you just had a function that applied to some new data, you'd set this up differently, but this is a function of this object here. So it has parentheses, and I think but if it's an attribute of it, then it doesn't have, I think that's what it's called. It doesn't have parentheses. So that is the shape of this data frame, which is 5 by 4, again, counting from 0. Cool. Okay, anything else interesting? Oh yeah, .unique. So yeah, there's a bunch of different, unique is also, okay, data frame object has no attribute unique. Oh, right. Okay, does it have a, okay, that's fine. Good stuff. Okay, wait, there's no unique. Yeah. Okay, oh yes. So unique does not exist on data frames, but it does exist on a column of a data frame. So if I did treatment dot unique, oh, key error treatment. So I made a mistake. Treatment. Oh, so I made a typo in my original data frame when I defined it. So that's going to come back to bite me, but that's okay. So treatment unique, and then it gives me the unique values. So a single column in a data frame is called a series. Just yeah, details. Okay, and what else can we do? We can subset a data frame. So we could say give us the data frame where the data frame treatment, or treatment in my case, treatment is equal to drug A. So that subsets this data frame just to give where treatments are drug A. So that's just like a filter in Microsoft Excel where you apply a filter to it. But you can codify the whole thing and work on millions of rows very, very easily. Good. So okay. And I think we covered all that. Tail, unique, experiment. Good. Any questions about data frames? Anything? Good stuff. All right, cool. So yeah, have a think if anything comes up. Otherwise, we can push on to the AI workflow part of the session. So yeah, we'll have a couple of hours to work on this, which is good. We can sort of write down as we get more and more into the weeds. I think so. Let's go. Okay, so in this, okay, let's talk a bit about AI. So obviously, we want to present Python as it can do so many things. AI is a very big word. I think people are using it more and more often just to describe things like Gemini, like ChatGPT, just large language models. However, it does encompass like so much of data science and stats and maths and all these parts of machine learning that we almost take for granted now because we can do them really well. But we'll focus on the large language model aspect of AI in this as we talk through. But we're happy to talk more about any of the other parts as well. And so Python has been a huge force of nature in developing sort of AI workflows, and I think that's due to its open source nature and its reproducibility and how anyone can contribute new packages and libraries. So what you find when you work in this space is that, especially with AI, new tools and updates to the packages are coming all the time. So you're going to run a workflow and it might not work anymore because you may have just installed the data, but they changed like the function names or something around. So it's been kind of annoying. Yeah, working with Python is great like that, but it can evolve very rapidly, and sort of you have to keep up your package and your environment safely, keep it all nice and sanitized with the workflow that you're doing. All right, so yeah, sorry, that was a bit of a segue, but we're going to talk about a particular large language model called Gemma. So Gemma is a family of open models. So a lot of models aren't open source, like so I don't think that the training data and the methodology behind Gemma is not available, so that's closed. But the weights, so the model, I guess the how the model behaves, that has been released publicly. And so what that means, you can take the Gemma models and then you can continue building off the Gemma models, which is great because the Gemma model's been trained for probably weeks and weeks on all the data sets that Google has available, and then they're released into the wild for people to build and make them more bespoke to their own needs. And so that's the Gemma models. And we are going to download the Gemma models. There's a few ways to do that, and we'll talk about that. And then we're also going to look at the Gemini models. So Gemini are the closed source sort of version of the Gemma models, probably trained and built a slightly different way. We don't have access to the model weights, but we can use the model weights. So that's the same of things like OpenAI and ChatGPT. We have no idea like how the model's working in the background, but you can make a request to it and say, please, answer this question, and it can give you back an answer. But with Gemma, we can sort of understand a little bit more about what's going on. So the reason I mentioned like the speed of development and everything is because there's a bunch of different ways at the moment. Like there's no sort of one source of truth for how the best practice to interact with these models. So we're going to be using a package called Keras, which has been around for years, sort of before the AI sort of hype really took off. And that's built on top of sort of a lot of other packages, mostly TensorFlow, but also you may have heard of PyTorch and JAX as well. So Keras kind of plugs in on top of them. And so one of they're developing. Keras just kind of like feeds into these other Python packages. And so you don't have to, you kind of abstract it away from the details somewhat. Okay, so let's do that. And we'll need, there's quite a few moving parts to this as well. We'll try and sort of get this set up before we have our next break. We're going to have to install the package, which is Keras Hub specifically. I think that's all we need to do. And then we are going to then download the models themselves. So that will we'll do that via this site called Kaggle. And then from there we can interact with it. Okay, then later on, after we complete that, we're then going to go see how we can query a large language model directly from Python via an application programming interface, an API. So we can make a request to a website and say, hey, can you please answer the question for me? And that's using the Gemini model. So that's if you want to use some really powerful model and you don't have like a supercharged GPU or something. You can use web-based models instead. So we'll do that as well. Cool. So let's start with going to Kaggle.com. Let me post that in the chat. Oh, sorry, I just only just saw those questions. Sorry, that question is, can you index a row by its row value on the left? Yes, you can. Is the short one. Okay, so Kaggle.com. So Kaggle is a super fun website, especially if you're getting into AI and data science and everything. It provides a place or a platform for data science competitions. So people may have like some complex data set and they want people to analyze it, but they may not have the skills in-house to analyze this data set. So they'll put up like, here's someone's put up a $1 million prize for creating an AI capable of novel reasoning. So that's basically an award for someone who can come up with an AI that can do some reasoning. So some of these, it's a more traditional one. Here we go, Aerial Data Challenge. So I think Ariel is looks like a satellite of some kind, and the data that's coming down gets fed into probably some huge database, and this competition is worth $50,000. You can go and try and come up with like a method to, I guess, digest that data nicely, maybe pull some insights out of that data, and yeah, if you do a good job, they'll give you $50,000. But so this whole platform is around data science, around data, and you can also download all the models that you might want to use in your data science, and so that includes Gemma. So if I look up Gemma 3 specifically, I think we're up to the third version of Gemma. Excuse me. And I click on models in Gemma 3. There you go. So you might have to do this. Watch this in the chat as well. So in here, this is what's called the model card for this particular model that has been released. So Google, they create the model, but then they need to release it into the wild. There's a few ways to do that. They can have a download button on Google.com, but more likely they want to, get this into the hands of people who are doing these kinds of workflows. So Kaggle is a good distribution platform for that. So you can upload a model that then becomes available to the public to download. And so Kaggle's one place. Another site that is quite common is Hugging Face. So Hugging Face is all about models as well. So you can download Gemma 3 from there as well. Yeah, so Google Gemma 3, and you can this is what's called a model card. It basically describes what the model is, what's it used for, some details about the model, how to use the model, and what it was trained with. So okay, but the important thing that you will need to do today is up the top. It says you've consented to the license for Gemma 3. So I'm logged in. Make sure you log in on Kaggle and click on. I think up there previously was a button that said consent to the using Gemma 3 responsibly. And then I'll tell you how to download it in a second. I just want to point out a couple other items. So, oh yeah, here. So if you click download, it takes me to the bottom. And I mentioned all these sort of environments and packages of ways to interact with models. And so today I'm going to teach you Keras. And if you click here, you can see all these different variations. So like I said, it's a rapidly evolving space, and there's no sort of one format to rule them all. So all these, the models get released, and they might just have to be converted into the right format for the framework that you're using. So we're using Keras, so that's that one. And then I'll talk about the variations in a second, but then you can download it there. But if you're using PyTorch or Transformers, which is another framework, or Gemma C++ or ggplot, and so on, there's all these different sort of formats. And then within the framework, so first you pick the framework that you want, and then you have to pick the type of model you want. So Gemma has been released with different I guess different number of parameters. So they might start with the same training set, but then train it in slightly different ways. So so the models might be more powerful, but they might be much larger. And so if you have a large model, fewer people will have access to the GPUs and computational power to use the really large models. So you might just be happy with a smaller model, especially if the task is something really basic, like if you just need to, answer a question. Is this paper relevant to my field of study? Yes or no. Like that's all you need. You can use a very small, lightweight model, and it's computationally cheap. So if you have a very large model and asking that question, it's going to cost you, a lot of computational time, which in reality turns into like money. So someone has to pay for that computation every question you ask. So anyway, there's a bunch of different model variations, and some of them are good at answering questions. Some of them are like base models, which are good to start with, that you can then build on and train and convert into what you need yourself. And yeah, but basically, so what you're looking for, 1B means 1 billion parameters. That's about the smallest model you'll see these days. And that usually equates to about 1 gigabyte of storage, and also about how big your GPU needs to be. So as you go up from there, they get very, very large very quickly. So the largest Gemma model is 27B. The OpenAI weights and things like Llama, I think they're like 400B. So and Gemini as well, they're huge, but they're closed anyway, so it doesn't really matter. Except not Llama, Llama's also an open model. Right, but you need a massive GPU to be able to run them, so not many people can. Okay, cool. So that's the variants. So you pick the type of model you want, and then the framework you want, and then the variation you want, and then you can download it. We're going to download it all just directly from our Python notebook, so we don't need to worry about this anyway. But I thought that was useful background, because it took me a long time to get my head around like which model do I want? And the answer is, it depends. So, okay. So in order to download it, you'll also need to go to your profile. So there. Wait, no, it is in settings. Yes, okay. So go to settings. Put this link in the chat. And click on create a new token. So down here where it says API, in the settings, click create a new token. And it says generate a new token will automatically expire any previous key. So you may or may not have one, but keep that in mind. So what we're downloading is kind of like a password to Kaggle that we can use straight from Python. So excuse me. So where's my downloads? So I just downloaded this file. It's just a, let me see if I can open it in, open it in my web browser so I can see it. Okay, so I downloaded this file. It's literally a JSON file, which is just, you can look at it as a text file, and it has my username, and it also has a password there. So never share your password or your key with people. But the cool thing about these API keys is that I can just go and revoke it and get a new one straight away. But yeah, basically you're going to need your username for Kaggle, and you've got to need this password, and we'll use that to log into Kaggle and be able to download models straight to Python. So because I just exposed it to everyone, I'll just go and click expire token, fantastic, and create a new one. And so, you know, this is great practice if you accidentally, you know, share your API key with people. It shouldn't matter, because you should be able to very quickly get a new one and expire the old one. Super. Okay, so we might have a break here, and when we come back, we will install this. So we'll start a new notebook, we'll install this, and we will then put in our username and password and go from there. Okay, so again, let's have a 10-minute break, and yeah, then we'll come back and we'll actually start using this. So that was a brief intro to Kaggle and sort of what we're doing and why we're doing it. So I've just spoken through all this stuff. Hopefully you've all agreed to the terms of service. Again, it's all written down what I've said, but there we go. Okay, let's have a break and I'll see you all again. Righty, welcome back everybody. So let's get stuck in. Question in chat, fantastic. I will see if I get the same error when I run this in a moment. Okay, so what I'm going to do, and if everyone wants to follow along as well, you can work in the same notebook. I haven't really given much attention to my old notebooks. When I go back on it, it says runtime disconnected. That means the resources that were allocated to it have kind of been revoked, and that happens on Google Colab. They time out after a certain amount of time. You can reconnect it. Keeping in mind you lose kind of all the things in memory. So like all the printouts and everything are there. But if I said what's pH level, it will be like that's not defined yet. So you have to go rerun everything. You can save these. You can go up and give it a file name at the top. They all save automatically. But if you want to give it a specific file name, you can do that. I will not keep mine for now, which is fine. Well, actually, they'll still be there. I'll go clean them up later. They'll just be called untitled something. Okay, so I'm going to go file and new notebook. And in my new notebook, I'm going to run that very first command, the pip install Keras hub. Okay, and yeah, hopefully it works. So pip install Keras-hub. So you can, these other flags, I'll do them too because they're in the notes. The -Q means quiet. I actually might get rid of that one so I can see everything that happens. That just means quiet, like don't print everything to the screen. and -u means update it if Keras Hub is already installed. And this % time, I put them in the notes. That's just a Python notebook thing. It's not a Colab thing. It's not a Python thing specifically, but it's just a shortcut to time how long it takes. So you have some indication of how long it's going to take to complete this step. In this case, 32 seconds, and I think that comes up in a few other places. Okay, cool. So mine said requirement already satisfied. That's okay. All right. So it looks like I got this error as well. I think it's fine. So it just says that it's tried to update some packages, but it has so it's trying to update Keras Hub, but then some other packages can't be updated for whatever reason, and so Keras Hub won't be compatible with those packages that can't update. Which I think will be okay for us because we just need to do some minor things. But then at the very end, it says successfully installed. So hopefully that's okay, Rob, if you got that same error as I did. Cool. So we've installed that. The next thing we're going to do is then log in with our Kaggle credentials. So I'll just really quickly do what I did before the break because I've revoked my key and I don't have a key, I think, or maybe I do. I'll just do it again anyway. So on Kaggle settings, I'm going to download an API key. It's downloaded it to my download folder. I'm just going to open that up in another window so I can see my key. And here, I'm going to run these next. So now I've got my key and I'll run these next steps, which are firstly importing Keras _hub. And we're going to also import Kaggle hub, which is already installed for us. That's why we didn't have to install it. And so we're going to use Keras and we're going to use Kaggle. Okay, so Kaggle hub login. So I run this command, and this is where it will say, please put your username in. I'm going to paste my username from that file I just downloaded, which is GDG for science. That one I could share. Fantastic. And my key should paste hidden. Login. Done. Credentials validated. Please speak up if that did not work for you. Good stuff. And then the next command is to download the model. So I'm going to say Gemma equals Keras _hub dot models dot Gemma 3 causal LM dot from preset. And I'm going to say Gemma _3 _1. Oh, sorry, it's Gemma 3 _1b. And I think that takes about a minute. Okay, so while that's doing that, I think this bit's kind of confusing for me. So Google owns Kaggle and develops Keras as well. So they develop Keras and TensorFlow, but they're all very, very kind of siloed things. But sometimes they work really well together. So there is some like overlap between the models are visible on Keras, but they actually get accessed via Kaggle. So it can be a bit confusing, like where the source of these is coming from, but it is kind of like the same source. Okay, fantastic. That worked for me. I didn't get any output like in the notes, so maybe that's been updated to not show it. But I have this object called Gemma, and it's a model ready to go. I can also go and look at what this is. So basically what we've downloaded is the Gemma 3 model weights, and specifically the 1B variant of that. So just the 1B and nothing else fancy. Now these models, people don't use them that much just for straight out of the box. They'll take this and then they'll just tune it to whatever they need, which we can demonstrate. We won't do the tuning, but we'll see how this behaves basically. So if I type in Gemma.generate, Keras is a, and I'm just going to set a, so this is going to call the large language model that we've downloaded to our local computer. So this is not going out to the internet. We're on a Colab, but we're not going out to the internet. We're just using this local model in memory. In fact, you can see our system RAM jumped up when we loaded this model into memory. And I can even show you where that is in the browser, which I might do in a second. But what we're doing, we downloaded the model and we set it to this value here, and then this object type, which is defined by Keras, just like we had a data frame in Pandas and an array in NumPy. This is a type in Keras. So we have this Gemma 3 causal model. So Keras knows what Gemma is, and they've actually written functions specifically for the Gemma models. And then using that, you can say Gemma.generate, and you can call your model directly just with that one sort of query. But we want to put a stop on there. So I said, only give me 50 tokens. So a token it's kind of like a word. Sometimes it's like half a word or maybe multiple words. But yeah, it's basically the currency of large language models. It costs a token every time you ask a question. Like that gets broken up into these things called tokens. And when you get a response, it's broken up into tokens, and they define how much work happens on either end. And so yeah, a token is like can be a phrase or a word or a letter or something. So it says Keras is a deep learning library for Python. It's a high-level API for neural networks. It's a Python library for deep learning. It is a library for deep learning. It's a library for deep learning. And that probably would have gone on forever. So you can already see, like, this model's a little bit unstable. It started really well as a sort of predictive text model. It said, Keras is a deep learning library for Python. Fantastic. It's high-level API for neural networks. Fantastic. There's a Python library for deep learning. Well, that's getting repetitive. And then it keeps repeating itself. So yeah, you can see these small parameter models. They're designed not to answer all your questions immediately. In fact, if we ask it a question, Gemma.generate, and say I've got in there like what even if I said what is Keras, I think actually I'll do the example. What year did Titanic win an Academy Award for Best Picture? And I'm going to put in max length equals, let's say 200. Why not? Okay, and that'll take a minute or so. So when we ask this, we'll see that the response is probably not very useful for anything. And while it's thinking, I'll just show you a little bit more around Colab. So in here, I can click on Files, and I have a workspace there that has like some sort of data in there. Comes with some sample data in every Colab, which we'll use in the next hour. And I can navigate. We basically have a computer, a Linux computer here. I think I'll have it written down somewhere where it's stored to. What I did. Oh yeah, there we go. So it's in excuse me. It's in root.cache.kagglehub. Oh wait, where is it? It's not there. Maybe it's in Keras. I want to refresh it. I don't know. I'm not sure where this is downloaded it to. Hide hidden files. No, show me hidden files. Okay, I wanted to show you where that downloaded to. So I had this written. That's where it used to download it to. It's probably been changed in an update. But you can see that it's just a file, you know, on your computer. It's nothing magic or anything. Oh, there we go. Kaggle, is it in there? Gemma 3. Yeah, this looks good. 3. Okay, yeah. So these are the weights. So that's the big file. It's probably a gigabyte or say. So it's in H5 format, which I think is HDF5 format. Might be the way that the weights are stored. Then it has all this sort of metadata around it, and you can actually you can open these up. Like they just describe sort of how the model was built. But anyway, I just wanted to show you that you've downloaded this model to your computer, and you know it's not going anywhere. Your data is not being transmitted anywhere. So it's so any questions you ask it are all happening within the confines of your own environment, which is cool. Okay, so I'll minimize that. Okay, so this time it's gone a bit crazy. What year did Titanic win an Academy Award for Best Picture? And it says, what year did Titanic win a question mark? And then it's given me a new line character. And then it just repeats the question again and again and again. That's really not very useful. So this is because large language models were originally great at filling in like missing words and predictive text. Like that's all they are. They've been shown all these types of text, like being trained on sort of Wikipedia, like read all these Wikipedia articles. And so if you type in something, it will just come up with every single piece of text that it's ever seen, every single token it's ever seen, and give it a probability distribution for which token it should display next. And usually, you know, some will never get shown, but some have really high probability, and so it shows you the best one. And you can actually, within Python, you can drill down and have a look at the probability distribution and look at what other options are available. Some open models and some models, like on the website, allow you to adjust what's called the temperature and top P, which kind of adjust which sample from the probability distribution, which one it's going to pick. But generally, you don't have access to that, and you just kind of get what you get as the first one. So anyway, in this, it doesn't know, I guess, what the concept of a question and answer response are. So what people have done is then fine-tuned this base model, the Gemma 1B, on a set of question and answers. So then you know that the model is aware of what a question is and what the user is wanting in response to that question. It doesn't just want to predict the next word. It actually wants to go and give you some sort of reasonable return response. And so that's what these instruct models are. So so we're going to download one in a second. Sorry, I just got looking at these, I got the attribute error. Module Keras has no attribute Gemma 3 calls. So when you ran, interesting that you got that error. Okay. So make sure you update this pip install Keras hub. Keras API model says no attribute. Yeah, okay. Look, let me just this is interesting. Some of you are getting that error. Make sure, see if you have anything different here. So mine says successfully installed Keras Hub 0.2.1. If you're not using that version, it might be some older version of the Keras Hub framework. So if I search for Gemma 3, actually specifically I want Gemma 3 causal. Yeah, the older versions may have had like a different syntax, or there's slightly different I guess so some of these are Gemma causal, I think, used to be the old one before Gemma 3 models came out, and they probably exist. That's all I can think of. Okay, but the model doesn't run with that error. Keras. Okay, yeah, so Yanni, it says 0.18.1, which is the old version. So run the pip. Oh, sorry. Run pip install and make sure you have a -u there, and that will hopefully update it to the latest version. And then that will give you access to the to this command behaving that way. I think that's what the problem is. Good. I'm glad I introduced that problem of these things are evolving rapidly. So we're experiencing this. Often happens where you'll go like, that command doesn't work anymore, and you're just going to make sure you're using the version that you think you're supposed to be using. So give that a go. !pip install -u. So the -u updates it and Keras Hub, and then try again. Meanwhile, we're about to break things, I think. Oh yeah. Okay, let's we're going to define a new model, and this time we're going to download the instruct model. So we're going to have basically the exact same line as before, but this time the instruct model. And I'm pretty sure this will break my code. Oh, mine's not defined. Keras NLP. Keras Hub. Okay. So we'll see if this breaks my might break my whole Chrome my whole Colab, because it might run out of memory, which is fine. We're learning about how to work within the bounds of our environment here. So downloading, this is a completely different model. Well, it's not completely different. Sorry, it started as the same Gemma 3 1B model, and then it has been fine-tuned on question response answers. Let's see if that works. Okay, yeah, I noticed a mistake here between the notes and the and what we need to do. So it says Keras _NLP. I think that should be Keras _hub. Change that there. Hopefully that works. And that may have been related to some of these errors, now that I think about it, maybe. Okay. All right, so that'll take 30 seconds to download. And what we're going to do is download the instruct version, and then we can ask it the same question and see how it responds to that same question, and we'll see the response we get and how it behaves. Okay. And I can see it probably downloading into my, where is it now? Kaggle, import, number 3, Keras. B. Where does it put this on? Probably in the same spot, but maybe it won't appear there until it's finished. But I'm waiting for this to die as well. I might have to repeat this in a second. Let's see if it works. Oh yeah, okay, so your session crashed, automatically restarting. Basically I ran out of RAM, so I kind of wanted that to happen just to show. I'm gonna have to rerun all of this because it has failed. Yours may have failed too, so you'll have to rerun it all. There's a couple of tricks to get around this. So the runtime, I'm just gonna click change runtime type up here, and Colab not only has access to Python, they've also got the R programming language and also Julia as well. We're using Python, but you can select also these hardware accelerators, which is basically GPUs and TPUs, which are kind of they're called tensor processing units. They're GPUs specifically built to do deep learning and AI problems. But also the TPU ones have a lot more RAM, which is a nice little hack if you want to get some compute there. However, I'm going to stick with CPU just because. But if you want to change it, feel free. They're not always available. Sometimes it's high demand for them, and they might not be available. Then you can upgrade to Pro and then have confirmed availability. But anyway, my session has restarted, so I need to rerun this. I'm gonna have to rerun everything again. I can sort of run it all. I'm gonna skip this one where I download the 3B model, the 1B model. So I'm just gonna comment these out. I'm pressing Control and /. So in case, so press Control or Command on Mac to make a comment, or to comment a line. Okay, I'll log in with my credentials. Science. And this is good because, yeah, it's just learning the environment that it's broken here, that it can break. Okay, I'm just going to comment these out so I don't run them. Good, I'm logged in, and now I'm going to download this model again. That one, I think it should be faster, maybe, because I think it's already downloaded it. Let's have a look. Kaggle input, Gemma 3. Oh yeah, so it should load quicker because even though my CPU crashed, it keeps my storage, which is cool. So it shouldn't take as long to load that model in. And then we have the instruct model. Super, I'm in. All right. Good stuff. You've got a crash as well. So yeah, just important. You need to install Keras Hub to update that. Log back in. You can skip all the other lines, and you just want to run the Keras Hub models Gemma 3 casual LM from preset Gemma 3 instruct 1B, and then we're back online with the notes. So you can ask this same question again and see how it behaves. I might just copy it. Gemma.generate. Maybe I'll just do 100. It'll be a bit quicker. Probably even only 50 is needed because I think it takes about 30 seconds. So I think even if you selected a GPU accelerator, you're not actually running it on the GPU unless you specifically tell it to. I think it's only like one extra line to say running this on a GPU if it's available. But I haven't configured that. So I'm running on the CPU. Okay, let's see what the answer is. And then the point of this exercise, hopefully this will give us a good result. And the point of this exercise is then we're going to ask it a follow-up question. And we're doing that to ask or to think about the context of the large language model. So when you log on to Gemini, you know, you ask it a question and then it gives you a response, and then you can ask it another question and then you give it a response, and you can have a conversation. Okay, cool. So we can try and have a conversation with this. What year did the Titanic win? So that was the question. Titanic won the Academy Award for Best Picture in 1953. Do you know why it won? So it's still rambling a little bit. The film was a commercial success. It was praised for its stunning visuals. Yeah, so it is. It's still coming up with these question response things. So yeah, these 1B models can be a little bit wild, but let's just ask it a follow-up question. Gemma.generate. What else did it win? And max length equals 50. And we'll find that this, we haven't passed it any context. So it's completely forgotten that we asked it about the Titanic. And also, this is incorrect. I don't think it won in 1953. I think it won in the 97 version. So keep that in mind. This is a great example of, you know, hallucinations. So yeah, we asked this follow-up question, and what we'll find is that it has no context of it. And so what's going on in the background of like an online platform like Gemini or ChatGPT or Anthropic or something, is that it every time you ask a question, you're passing the entire context of the conversation, and there's different ways that they do that in the background, but we can write our own little function to pass the context to Gemma here, and so it knows like our conversation history. All right, so yeah, what else did it win? And then it starts talking about the Olympic Games. So it's totally off on a tangent, but we can do this. Now, in order to do this, I think that everything in this function is just things we've learned today. So there's nothing sort of new here, but just getting the logic down right that you want. So there's sort of two parts to it. We need to define. I'm just going to talk through this because it is quite complicated, but you could do this yourself using the tools and the techniques you've learned today. So we define a conversation history as an empty list. So we can define an empty list, and then you give it a question, and the first thing you do is you have to append the question to our empty list. So I'll copy and paste this in. Yeah, this might be hard to follow along. Let me just remove all that buffer. Okay, so I define an empty list. I ask this question, and I stick it in there. And also, when you're dealing with large language models, so here's what's in our list at the moment. They're literally just text-based models. So they sometimes they don't understand the difference between themselves and the user. So as we can see by this question response here, so you have to kind of like teach it who's asking questions around here. Yeah, who's asking questions around here and who's answering it. Because here it just ran away with it and started asking questions and then answering it of itself. So you can do things like this where you define, like, you come up with your own syntax as define, like, this is the user role, so we're the user, and this is the question that the user is asking, and we can slowly append to this, and we can say, okay, this is the system role or the LLM role, and this is the content that they're generating. And so we can build up this structure, and then we pass that context back and forth. Okay. So in here, we then need a function which sets up that structure in a nice way. So I'm just going to copy and paste this, but basically all it does is I'm going to run it, define the function, and then I'm now going to say prompt 1 is this function with this conversation history. Okay. And then I'll print out prompt 1. And so what I'm actually passing to the LLM looks a bit like this. So start of turn, user, what year did Titanic win an award for best start of turn model? So I might just send this now. So Gemma.generate. Let's go prompt 1. Prompt 1. I'll do a time. Okay. So while that's thinking, we then need to capture the response that is received, and we need to append that back onto the conversation history list. So that's what we're doing. We're basically building up this conversation history, and we keep going back and forth. So this is what it returned. But it did not win. Okay, so this has already done a better job now that we've been really strict with, like, start of turn, user, what year did this happen? So that's user, and then start of turn, model, and then the model steps in and goes, okay, Titanic did not win an Academy Award for Best Picture. It was nominated for the award, but it did not win. So that's good. We're already making progress just by giving the LLM a lot more, or being more restrictive with it. Okay, sorry, but I wanted to capture that answer. So answer 1 equals that. And good. And then we can, yeah, basically ask another question and then append that as well, and then get a second answer. So I might just copy this whole thing. Yeah, feel free to just copy that. Answer one, so that's answer one there. Conversation history append. So I'm going to append that to the history, answer one. I'm going to ask it a second question. I'll remove the print statement so it's a bit clearer for what's actually happening. So set up our conversation history with the role, user, content again, and then format it into prompt 2, and then I'll put that in another cell. Okay, so prompt 2 is going to look like this: start of turn, user, what year did that win? And then it gives me the end of turn and says Titanic did not win an Academy Award, and then it says end of turn, start of turn model. Okay, very good. And now I go answer 2. I'm sending that entire like string of instructions to the LLM this time, and we'll generate it. See how we go. And then we'll see the answer for that one. Oh, that's good, Rob. That, yeah, it works with the TPUs, so they have a lot more RAM on them. I think one of these they've got 12. I think the TPU machines have like 100 or something. So substantial. Super. And then once we finish this, that's our local model. So yeah, just reiterating, like, having a local model is fantastic. However, a lot of the time, you know, you may not have a machine that can handle a really strong, really big local model. If you do use the GPUs on here, I think you get a pretty big model, at least the 7s, maybe even 27s on the TPUs. And then, yeah, then you can ask questions of your data. I haven't really spoken about uploading data and everything, but you can just basically drag and drop data into the that's my home directory. User, no, home, media, home. There we go. So my home directory is, I think, that one, or maybe not. Content, I think it is. Content's the home directory on these. You can drag data into there, or you can connect it to your Google Cloud or something. All right, let's just have a look. Answer 2. Did it get there in the end? So what years did it win? Okay, let's look at the awards Titanic received. Here's a breakdown of its major accolades. Best Picture, Best Director, James Cameron. So it's mixing it's kind of mixing years up here. It's a bit confused, but you know, it's doing a better job at responding the way we want it to, even though it's getting the factual information incorrect. So I think that's a really, like, interesting insight into how LLMs think, and, you know, what they're good and bad at. Okay, but are there any questions about that? How can I find the local directory of the model? So you can download it wherever you want on your computer. If you download it using the Keras Hub models auto downloader, you might even be able to set like the download path in there. But basically, how do you find it? That's a great question. I forget how I found it. But it's in the top level directory. So you probably started in content. You need to go up a directory, and then it looks like it's downloaded to Kaggle, input, Gemma 3, Keras, and then it's in there. They're the models. And yeah, so you can download those directly to your computer. Again, you can go and do this back on Kaggle as well. So look up Gemma 3 again. Models, Gemma 3. So if I click download, I can download it in whatever format I want. It even says, like, here's how you download it using different things. So I can download it via Kaggle Hub, the Kaggle CLI, curl, or I can just click the tar.gz, and I download a zip file of the models, which yeah, now downloading. Cool. And so they'll be local. I can unzip that, and that'll be the exact same files that are in here. But then loading it in and yeah, unpacking it, making use of it, that's the next step. Okay, super. So for the next section, we're now going to query. We can see, Gemma 1B, fantastic, it's great. But, if we want something a lot more powerful, then using an API to query a service can be super helpful in your workflow. So yeah, I've written workflows that are standard Python scripts, and then occasionally they'll just ping out and be like, okay, here's all the data. Now ask the LLM a question about that data, and then it asks it, and then it gives you you can say like, give me a yes or no response, and it'll give you that. And then you can say, if yes, do this workflow. If no, do that workflow, or something like that. So I'm going to do that. 1:40, good timing. We can set ourselves up and then have one more break, I think. Okay, so let's go. So we're going to go to Google AI Studio and get another API key. Now, the reason I've done, we got an API key from Kaggle, and that's great for all the Kaggle related things, like all the models. Now the API keys from Google AI Studio. AI Studio, let me just give you a browser around here. It's basically, where's my studio? So you can come in and chat directly in here. And I mentioned like you can adjust like temperature and stuff in here. So if you went to like the Gemini interface, can I go to Gemini? Or like the ChatGPT interface or something. Oh, sorry, it's opened up. It's opened up something else. Why can't I open it in the browser? No, it won't let me open it in the browser. Anyway, it's yeah, basically the chat interface of Gemini. It doesn't give you access to any of the anything under the hood, but here you can do things like adjust the temperature. So that's how kind of like how crazy the model might think. Like it might pick, instead of just picking the top value from the probability distribution, it might be a bit more flexible in what it does. You can test a whole bunch of different models. What else? Oh yeah, you can also do the multimodal. So Gemma is multimodal, and so is Gemini as well. Yeah, you can set all these different options. But the thing we want to use at the moment is just the API. So we don't need to worry about that. And so you're going to go create an API key, and you can I think you should be able to just select whatever you want. Oh yeah, here, if you pick Gemini API down the bottom, I think should be available. I've got a bunch of different Google Cloud projects. But if you click create API key, it'll give you a key. Again, don't share this with anyone. Everyone can see it, but that's fine. I'll just revoke it. And I can, yeah, I can copy that. So I've got two API keys here. I think if I click that, yeah, I can get it again, click copy. I'm going to use that in our Python workflow. So let's go. Credentials, cool. All right, so that was it. Is anyone struggling to get an API key? But we'll just set ourselves up. You can probably, yeah, you can keep using the same notebook, or you again create a new one. We can keep it separate. So yeah, and this is true for all of them. Again, Anthropic and OpenAI and everywhere will have somewhere where you create this API key, and you then have to get the key, and that's your gateway to the service. You may have used API keys for other things, and there's often a free tier, so we're just using all free tier stuff, which means like you can only query it. I think it's the free tier limits. It might have the limits written there. usage data, pay-as-you-go pricing, usage and billing, not sure. API. Yeah, anyway, that there, oh, it's probably in my notes here. So credentials somewhere. Yeah, it has the limits, and I think it's about like 20 queries per minute, and like a total of 1,000 per day, and a total of 20,000 per month or something. So it's quite substantial, the free tier, which is good. But it also factors in how many tokens you're requesting. So keep that in mind. All right, but here's what we need to do. We just need to import this library. So this is a specific Google one. So from Google, import Gen AI, and then you don't need the second one that's in the notes there, but you need client equals Gen AI dot client, and then API underscore key equals, and I'm just going to paste this in here. This is fine, I think, for the workshop. My key there, hopefully it works. Oh, too many sessions. I need to kill some of my sessions. Let's disconnect and delete the runtime. Hopefully that is okay. Let's try again. Seems to be working. Yeah, this is obviously is not a great way to store keys, but there's a few different ways that you can do this, do it more securely. And one of those is clicking this secrets button over here, and you actually has you can just import the key from Google AI Studio. You can give it a name and load it in. I think that's how I've done in the notes there. But for now, just pasting it in it should be okay. Cool. So I think that worked. So I'm going to type client. Fantastic. It is there. I'm just going to jump straight down to where we ask a question. Where's our question? Here. Response client models.generate content. There. Prompt. Okay. So we're gonna make a query about our houses. Sorry, a data set. But let me do that. Okay. So I'm going to ask a question of the model. Client dot models dot generate content, and then I specify which model I want to use. So this you can get from the model list, basically, or the documentation. Here, Gemini 2.5 Pro, Gemini 2.5 Flash, and so on. I think Gemini 2.0 Flash and probably Flashlight is cheap. Let's say we can use it abundantly without hitting the rate limits. 2.0 dash Flash dash light, and then the contents. So this is how you define it when you want to query it, and then the contents equals, and so now we just give it a prompt, and so the prompt could be, what year did Titanic win Best Picture? What was the question I asked before exactly? I got it the same. It was exactly the same prompt. So we can, what year did Titanic win an Academy Award for Best Picture? Let me just ask that and see what happens. Cool. And so it sends this like response back. Let me this is giving you far too many details. So what we can do is do something like response equals, and that just stores it in a variable, and we go response dot text, I think is the, there we go. So that's the response of it. Titanic won the Academy Award for Best Picture in 1998. The award ceremony was held to honor the films of 1997. There you go. So that's a much more to the point answer. This one is correct, as opposed to the 1B model. So when we come back, we'll have a break now, and feel free to ask any questions that people have in the chat or otherwise. But when we come back, we'll unpack some data, and we'll explore that data and then see how we can ask questions of that data using the Gemini models. But you can see, like, obviously this is much, let's say, more straightforward. You get the API key and you ask questions straight away, and it's a super powerful model. But you definitely need to have the use case of the local models through the Gemma models for some people. So okay, cool. So I'll set another timer, and then we'll come back and we'll keep kicking on and have a look through the rest of it. Good stuff. Making good progress. All right, everyone. Hour of power coming up. Let's get stuck back into it. Thanks again for joining on this Friday afternoon from wherever you're dialing in from. Now, I thought we just get into just visit something else real quick. I posted in the chat a quiz. It's a little fun little quiz from the site. They do sort of good Python training and introductory Python stuff. You often end up there if you search for a Python problem. But these quizzes they have are quite interesting. And I'm showing you real I guess use cases of Python and sort of applied Python workflows. And I feel like in science that's often what I did, and probably what you'll do as well, is that Python's a means to an end. It's just you need to get something done, and you just kind of do it, and often you only ever do it once. Whereas like programmers, developers, they build like software that does the same thing again and again. And so it's much more polished, and the understanding and meaning behind the software is more important, I guess. The code and like how performant it is and everything, and how it scales, which you generally don't need to worry about when you're doing sort of scientific workflows sometimes. Anyway, so I thought this quiz is kind of fun because it is it gives you some insight into all the things we've skipped and that you'd cover if you ever did a computer engineering or computer science sort of undergraduate course, or delved much deeper into the subject. So just a couple questions I'll run through pretty quickly. This is all about control flows. There's a bunch of quizzes there. Okay, what term refers to statements and syntax constructs that let you alter the normal sequential execution flow of your Python code? Okay, I think the answer is just control flow structures. I've been using a lot of jargon, a lot of terms. I think I've been getting most of it okay, but I could definitely mix things up. So, but there are formalized definitions for everything we've covered today. Statements like conditionals, if, and loops for while let you customize execution flow of your programs. So we kind of covered that. Okay, fill in the blanks. To write your conditional in Python, you start with so if you want to do a condition, you start with if, keyword, then a condition, followed by a colon, and then an intended code block that runs only when the condition is true. I think that's fair. Yep, good stuff. All right, which of the following statements about using elif clauses versus separate if statements are true? So select all that apply. Separate if statement, stop checking after the first true condition. No. So if there's an if statement, it'll check it. If there's another if statement, it'll check it. And in an if elif chain, only the first true branch executes. So yes, that is correct. So if something happens, that condition is met, and then it does its thing, and the rest of the chain is forgotten. In an if elif chain, all true branches execute. No. And so separate if statements allow multiple code blocks to run if more than one condition is true. Yes, I guess that's true as well. Right? Let's see. Good stuff. Yeah, so just little catches there, and for why you'd use an if, elif, else statement as opposed to like multiple if statements. Which statement about the else clause in an if, elif constructs are true? You can put a condition inside the else clause, like the else condition. The statement about the else clause. Oh, yeah, okay. You can put a condition inside the else clause. No, so else just covers everything else. You must have at least one elif. No, you can just have an if statement. The else clause must always be the last one in the. I think that's you have to have it set up that way. You can place an else before an elif without causing error. I don't think so. And the else block runs when none of the preceding condition is true. Yes, I think that's right. Good stuff. When you want to iterate over an iterable, what's the correct way to write the Python for loop header? For item in iterable, I think that one is correct. So for each, that's syntax from a different language. That looks like C++ syntax for item colon iterable colon, and that looks like syntax from another language as well. So let's go with that first one. Good stuff. What does the break statement do in Python loops? Jump to the next break in the loop, terminates the current iteration of the loop, terminates the loop execution, and resumes with the line following the loop. I think it's that one. So stop and break out of the loop. Good. When you write a recursive function, so we haven't spoken about recursion, where you have like a function call itself. So that's very fun problem in computer science. You always need two essential parts to make it work correctly. I don't know the answer to this one. An iterative loop to replace the recursion. Recursive case that makes the recursive calls. Yes, okay. And a base case. I guess those two things. Maybe. Yeah, cool. Yeah. So yeah, recursion. Yeah, it's confusing. Building likes the return statement never immediately exits a function and returns a value. Immediately exits a function. If you don't provide a return value, then Python uses none implicitly. Very good. So yeah, we didn't speak about the none keyword, just like true or false. You can have a value of none, which kind of instantiates a variable, but doesn't take up any memory, I think, and is none. We spoke a little bit about not numbers and nulls. Yes, okay. How can you catch multiple exception types in a single except block when they share the same handling logic? Multiple exception types in a single except block. So we didn't talk about try except, but it's kind of like an if else. Chain exceptions with the and put the exceptions inside a set. Put tuple of exception types in parentheses after except. I think that is the case. So this is what a try except looks like. To try, price equals int item, but if that errors or something for some reason, then you can do something else. So you can actually like break your code and then just keep running anyway, which is kind of cool. Python, I don't know, somewhat unique in that. What's the role of the case underscore clause in the Python? Okay, we didn't speak about match case statements either. I don't think have I used a match case statement? They come up occasionally. And this is like a special case. It stops the entire match, captures the subject value into a variable, serves as a wildcard. I think it's that one that matches anything if no earlier patterns match. Run for triangle. Yeah, so yeah, this case clause does that. Okay, so you have this code, count equals 0, while count is less than 5, print counting. Why does this loop indefinitely? Well, count is never incremented, is it? Print call, loop never updates count. Good stuff. So there we go. There's a bit of insight, just in that really simple quiz. We're going to uncovered a whole bunch of other Python that we haven't even touched upon. But yeah, once you know the basics, everything else you can kind of figure out from there. All right, back to AI. Any questions? Good. So while we were on break, your runtime may have gone to sleep. I think mine's still awake. That's good. It doesn't take very long to reinstantiate it. It's very quick and responsive. Very good. Still working. All right, so let's build out this. We've got about 50 minutes. Let's build out. Let's load in a data set using pandas. We'll have a little bit of an exploration of the data set. We can plot of some of that data, and then we're going to convert the data into something that is palatable for the LLM, and we're going to ask questions about that data. Okay, let's do that. So I mentioned earlier that you can upload data sets in here. Like I have, I don't really have anything exciting. I have my JSON file with my key. I can just drag it up there, and then it uploads that I've downloaded there. But Google Colab, it just comes with some sample data, so we all have the same data set. I'm just going to use one of these sample data sets that are in here to sort of explore. And to do that, we can say data frame equals pandas. Oh wait, I haven't imported pandas yet. Maybe I should do it. Let's just do it and see what happens. pd.read CSV, and then I want to be in the. It depends where I'm running from, but if I'm in this top level directory, then I need to be in sample data / California _ housing _ train.csv. And name PD is not defined. That is because we have not imported pandas. So I'm going to put a code cell above there, import pandas as PD, and I'll try that again. That's how it worked. Again, as a general convention and style, all the import statements generally happen at the very top of your code. And that's just because, if you get 90% through an analysis and then it crashes because you haven't imported something and you haven't got that package, it can be frustrating, I guess. So generally put all your import statements at the top. Okay, cool. So we have this data frame. I think it's quite robust. 17,000 rows, 9 columns. It is, I think it's a famous machine learning data set. It has it's about housing in California. So it's got it's all numerical data actually. So that's interesting. So longitude and latitude, then it's just got median age of house, number of rooms, or total bedrooms, population, households, median income, and median house value. That's good. Okay. So we can explore this data set. I'm going to just crop it quite substantially, just so it's a little bit easier to work with. So I'm going to say df short equals df.drop, and say columns. So I'm saying drop columns equals housing median age. Well, let me close this and maximize my real estate so people can see. And okay, median age, total with a string around it, total rooms and total bedrooms. Oh yeah, I've got a few more. Maybe I should have. Population we're getting rid of. So these are all the columns we're dropping. We're just making a very simple data set for ourselves. But I wanted to demonstrate sort of how pandas can kind of do this kind of thing. And I only want, let's just take 3. So df short. All right, so I'm dropping all the columns basically, except the latitude, longitude, median income, median house value. So I'm dropping all the other columns. And also I've strung this thing on the end, .head 3. I'm only taking the first 3 rows. So I'm keeping this just super simple for an example. That'll just keep our token count down later on. Okay, good. Everyone with me? And so, and just before we kind of use this one, we can still use our full data set to explore. If you remember, we had, you know, df.head, df.info. Not too exciting. df.describe gives the averages of everything. I think there's this thing called is null, which says is any data missing, and you can do a quick is null and then string things together with by putting the sum on the end there, and it basically says 0, 0, 0, 0, 0. So that's good. There's no missing data in this data set. It's quite a clean data set, which is very rare. You know, in reality, you can clean all this up, and Pandas is fantastic for that. That's it has a lot of tools for doing interpolations and filling in missing data and everything. Okay, and you can actually do plots in Pandas. We haven't spoken about plotting today, but that is something that is very important and very useful in Python. Pandas has its own little built-in plotting library. So if I do a scatter plot of the x equals median income and y equals median house, let's go value. Let's see what that looks like. So there's a massive scatter plot. So there seems to be some correlation between the median income and the value of the house, you know, up there. And I guess the whole data set is truncated at $500,000 for a house. We can make this a little prettier by setting the size with s equals 1 and the transparency, the alpha, equals 0.8. And then we can get like a slightly nicer plot. Yeah, Python, most plotting in Python is built on this library called matplotlib. And to do basic plots, you know, you can it's pretty straightforward. You can just type in some syntax like this. It's not too difficult once you've got your data in the right format. But then if you want to then, you know, massage it so it looks different, so you get like commas here between the thousand separators. Maybe you want to change the titles and move numbers around. It can become much more complicated, but you have full control over it, so you can kind of do anything. And you know, once you've done it once, then you can do it a million times, which is cool if you refresh your data or something. There's another package called Seaborn, which has some nice data exploration tools in there. So we can do SNS hist plot and look at the what do I want, the house value? Sure. And it has some options in here. KDE true, so kernel density kernel density estimate. So you can make some nice plots using the Seaborn package. Again, you know, you can read the documentation for all these things, and it looks similar to some other documentation we've seen. Again, like I said, some practice to understand how that works, exactly how it works. But this is a really nice sort of histogram of the median house values. I think you can see where that $500,000 sort of peters out there. They also have heat maps, which are cool. It's an s.heat map. EF. Not on so will that work? Maybe that'll just work on its own. Oh, yeah, so So we can yeah, look at how correlated each of the variables are. So it makes a heat map and correlation coefficient between each of themselves. We can add, add different extra things to it again to make it sort of make it look prettier. So annotations equals true. What does that do? That gives us the numbers on the plot itself. You can change the color map. So cool warm. A bunch of different color built-in color maps. Let's go Python color maps. There we go. There's a bunch of different color maps that are built into Python. And anything else? Oh yeah, we can adjust the format so we don't have multiple significant figures. Let's go 0.1 F. There we go. So that, yeah, there's a nice heat map correlation matrix of how correlated these variables are to each other. You know, when you're doing traditional machine learning, that can be really important, whether you want to keep certain values in or remove them. So there's a big correlation between the total rooms and the total bedrooms, which makes sense. Most houses, if they have more rooms in total, they probably have more bedrooms in total. So yeah, that was just a bit of a side exploration into some data analysis. I might just while we're there. Again, I mentioned at the start, sort of machine learning is a massive part of AI that isn't really spoken about in the colloquial language anymore. But scikit-learn that's the main, I guess, traditional machine learning package in Python. And this is a fantastic package. You know, once you've got your data into like a data frame, then it's super easy to just say, you know, predict where this data is going, like predict some sort of association between this data set. And yeah, there's a bunch of different models and everything that you can do. Classic regression model to fit data in different ways. Again, reading the documentation is good. Where's the scikit-learn flowchart? So choosing if you want to go down into yeah, traditional machine learning, they've got this great flowchart, which is like, hey, you know, I want to understand my data a bit better. I'll start here. You know, how much data do you have? Less than 50. Okay, get more data. If you got more than 50, cool. What are you doing? Are you predicting a category? If yes, do you have labeled data? If yes, then you can use any of these classifiers in here to make predictions. If you're not predicting a category, maybe you're predicting a quantity instead, you can do regression or some other method as well. And then if you're not doing predictions, maybe you're just exploring your data in some way. Yeah, you can do all these other steps. So PCA, and over here, if you're just doing like clustering analysis or something, again, with unlabeled data, and you just want to find some relationships in there, you can do that as well. So super powerful package. All right, where were we? So let's take this data set now and pass it to a large language model and ask questions about it. So when you ask questions of a large language model, basically everything has to be text. So even these smart, you know, models that you can upload like PDF documents to or whatever, they all get turned into text and tokenized. So that's what's happening under the hood. So if you're uploading a data set or a table or something, basically it will be fed to the large language model as text. Now there are yeah, the newer models, I think they're becoming truly multimodal, where they're being trained on that they know what a data frame is, and so you might be able to pass it a data frame, but I'm yet to fully experience that. So for now, most things eventually get converted to text when doing things. So if you're working natively and you want to ask questions about this data, you have to convert it to text. And so to do that, we can create our thing called data frame string and convert our short data frame to a string. And here's what it looks like. It basically just looks like there's our data in string format. So if we were to pass like our whole massive data frame, that's why I dropped it at the start, the 17,000 rows, it would be very long and probably be too many tokens for all you want. But you could sample it some way. I think the context windows for these are like, 10, it used to be sort of 8,000 tokens. Now we're up to hundreds of thousands of tokens that models can take. So it's pretty powerful. All right, now we need to write a prompt with that string. So we can say prompt. This is going to be the prompt that we say. Let's do an F string, and let's do a multi-line comment with 3 dashes. So we've seen all these things before, and now we can write, I have the following. This is the query we're providing to the large language model. The following experimental data, and let's put. Did I just lose everyone?
We lost you for a second.
Okay, I'm not sure what just happened then, sorry. I will reshare my screen. Share my screen. Cool. Okay. Sorry, I'm back online, I think. I'm not sure exactly what happened, but I haven't done anything. So we've set our data frame up to a string, and now we want to write a prompt to then fill in the details, basically. So I said I have the following experimental data, and so in here I'm going to pass it this string, and then after that you can then ask questions about it. So so please answer the following question about the data. So we've set up a nice little sort of prompt template. Incomplete input. I missed one quotation there. So incomplete input. So it was expecting the rest of the input. Let me try again. Good. All right. Okay. So a question, you can use your imagination. Maybe question 1. Where are these data located? So I'm hoping it comes up with the answer California. So full prompt equals prompt plus question 1. So that means the prompt is going to look like all this plus that, because you can just add strings together nicely like that. So our full prompt, when we look at it, looks something like this. I have the following experimental data, longitude, latitude, blah, blah, blah. Please answer the following questions about the data. Where are these data located? Cool. And so now we can send this whole thing to our model. The response equals client.models.generate underscore content. That's the method we're using. And model equals Gemini -2.0 -flash. You can play around with the other ones, the other options that are there. and then the contents that we're passing to the model is the full prompt. And let's run it. Oh, models, Gemini. Okay, I've made a typo there. So Gemmin 2.0 is not found on API version or is not supported by that core. So again, interpreting that message can be very difficult for if or not found. Basically, I made a typo and it can't find that name of the model. So I'll try again. Response. All right, and response. Remember, response looks kind of wild. It probably has, yeah, the number of tokens that we've sent to it. So the total cost was 230 tokens, which is kind of interesting. That's not very many at all. I think you charge like 10 cents per million tokens or something on most platforms. A response.text. There we go. Based on the longitude, latitude values provided, longitude is this. These coordinates place the datasets in Southern California, specifically in the general area of Imperial County in the eastern part of San Diego. How good's that? So there we go. And now we can ask another question. Question 2 equals, here's, I'm going to use nested quotations, median income and median house value represent. I've got any more notes. Oh, and I've said, oh yeah, let's do a multi-string so we can, what did me? And what insights can you draw from their relationship in this sample of the data set? Super. So there's our question 2. And so we once again can define our full prompt. Full prompt equals our sort of our setup prompt plus question 2. And then again, I'm just going to copy this. It's exactly the same. Sounds a bit, thinking a bit more. And response.text. Here's an explanation. Meaning some initial insights based on the small sample of data. Meaning of the columns. Median income. This likely represents the median income of households within a geographical area defined by longitude and latitude. The units are not explicitly stated, but are commonly represented in tens of thousands. For example, 1.49 means median income is 14,936. Median house value. So yeah, I think this is pretty good. For example, blah, blah, blah. Insights from the relationship in this limited example, even with only 3 data points, we can start to observe a basic trend. Positive correlation. Potentially, it appears as a positive correlation between the median income. So you can see already, like, it's super powerful that you can, yeah, you can convert your data into whatever format you need. Experiment, play around, and see if you can actually, you know, what happens if you pass a data frame. It probably will complain and say, like, hey, that's not text or something. Actually, I can just do that. Let's just do it. Contents equals, let's do df short. Oh yeah, okay. So it complained basically. If you try and just pass it a data frame, it will not like that. So, well, that's good to know. So invalid argument, message. Yeah, the message looks empty. Parts must not be empty. Cool. Okay, so I think that brings us kind of to the end of all the exercises. Oh yeah, all my things crashed. Okay, it's one I prepared earlier. So, oh yeah, okay, and so we're using this Gemini. Where is it? We're using this Gen AI package that's built into Colab to query it. It makes it really straightforward. But you can use, so OpenAI is probably the standard for asking questions of large language models, and the equivalent to do that looks something like this. So you have to define your API key and your base URL. So it's not too different. And then you set your model. And then the message, you actually have to define the role, the system, the content, and all that, kind of like how we did with Gemma. Yeah, so it takes a few more lines than just using the default Google Gemini sort of way. But yeah, this OpenAI is probably a standard that you will see in all kinds of places. So if you query like a Microsoft model or Anthropic model or whatever, most of them will take this format. So keep that in mind. And all right, where are we? Are there any questions at all? So think about it. I'll just sort of summarize and wrap up. So yeah, like well done. You know, today 4 hours on Zoom is can be quite painful. Thank you for listening and sticking it through. We covered some basic fundamentals, variables, and data types. Hopefully now any output that you see from a large language model, you can kind of like read it and understand like what it's doing. We spoke about the lists and if-else statements and conditionals. We spoke about loops, for loops and while loops, and we defined functions ourselves as well, and some complicated functions. We looked into libraries and packages, so we didn't have to reinvent the wheel every time. We can just leverage other people's great work that they've already done. We use the PyPy package manager, but you might use Conda as an alternative or something else. And yeah, we looked at NumPy and Pandas for tabular data, and then we kind of look at some basic AI workflows with a local model, so Gemma. And once you outgrow your hardware, if you don't want to buy a new GPU for your local machine or something, you can then go into the cloud and ask, use an API, use API endpoints. So we explored Google AI Studio there and asked questions of our data. So did some basic data exploration using Seaborn and Pandas again, and asked questions. And so yeah, it's like the use cases that people are coming up with for these large language models specifically are amazing. You see sort of new insights and everything that people are using them for. Like once you know it, like it's just a tool. It's not magic or anything. You can start to leverage it and go like, yes, I just wanted to answer like this particular question. I don't need to do everything for me, but I want it to something that I used to do manually that I had to go on and check or whatever. You can automate that process with them, which is cool. So if you there's so much more obviously to unpack, like the official Python tutorial, official Python documentation is good, and there's some tutorials in there. Again, that's probably like computer science sort of based, but it's still good. The Google Python class is actually quite good and comprehensive, very approachable and friendly. So that's a good one. And if you haven't heard of the software carpentries, carpentries were designed for specifically for researchers and scientists and people working in academia. So they realize, they're not developers, they're not computer scientists. They just want to use these as tools. And yeah, there's a bunch of other fun things. We spoke about most of these packages. I think we didn't speak at all about computer vision, and that's a whole other field of AI, I guess. But probably the main thing is they're all using these sort of machine learning models, depending on what type of model. So AI, like the large language models, and computer vision, they use deep learning neural networks. So we haven't really spoken about that, but that's a sort of similarity between them. And there's a bunch of extra libraries as well that you may want to explore. So no matter what domain you're in, there's probably a library that has a whole bunch of relevant functions. So I'm a geologist from back in the day, and there's a bunch of geoscience libraries that do things that only geoscientists kind of would want to do. But then there's astronomy ones and molecular dynamics ones and geospatial packages. And so question from Rob: what is needed to include text in the data set? Wait, that question means what is needed. This one. So I converted my data set to text using this toString method from Pandas. So you could you can experiment and see how far you can push the number of where do I there I find this df short. So I kind of truncate the data set. Maybe I can do like 50 rows. And then I convert it to text down here with df to string. And then I ask questions of it there. So let me ask that last question again. Question 2. See, so I'm sending quite a lot of characters this time. I'm curious to know how many tokens. There we go. Well, that was 2,000 tokens sending 50 rows of data. Yeah, so it's still not a huge amount, but 50 rows is quite a lot to have a little sample. And also it gives me sort of more interesting insights there. Hope that answers the question. Okay, so I think we're finished. Are there any final questions? Otherwise, be sure to come along to. We've got a bunch of cool talks coming up in the GDG AI for Science community. So we're looking at alpha genome next week, and then I think the following week we have this one's in person down at the Google office in Sydney. An overview of all the climate and energy research efforts that Google's working on. And then the following week, all about this new data set called the satellite embedding data set, which should be super interesting. And then later in the month, we're getting more into the weeds. So I'll be running that fine tuning your Gemma models into on your own data, which should be interesting. And finally, using large language models from R instead of Python for all the R enthusiasts. And I think there's a bunch more in the pipeline as well. So thank you very much, everyone. And I hope to see you all again soon. Farewell.